Section 6.3, the binomial model. So the binomial model is the model for discrete valued numerical variables. So these are the ones where we have whole number counts. So again, if you think back to 6.1, we defined continuous and discrete. So we've talked about the normal model with continuous, and now we're talking about the binomial model for our discrete. So to be a true binomial model situation, you have to hit these four qualities. There has to be a fixed number of trials. Only two outcomes can be possible on each trial. So something like heads or tails, or success or failure. The probability of success has to be the same at each trial. And the trials themselves have to be independent. So as long as you hit those four qualities, it would qualify then as a binomial model. The binomial probabilities are given in their own format. So again, kind of a recall, the normal model looks like N for normal, and then we have the mean and the standard deviation. That's what defines a normal model. So the binomial model has the B for binomial, and then we have N. N is how many trials are there going to be, because again, they're fixed. Whatever that is fixed. So we can know how many trials are supposed to happen. P is that probability of success, and again, that's going to be the same after every trial, so we know what that is. And the last is going to be X. X is how many successes are you trying to see? How many out of the fixed number of trials are we looking for to be a success? There are two formulas that you need to know and that you need to memorize for the binomial probabilities. So these will not be given to you. They are not built into StatCrunch. You need to be able to find them sometimes. Sometimes you can do it in StatCrunch, but sometimes you actually just need to find it. So do look at these formulas. This is the mean number of successes. To find the mean number of successes, you take however many trials you're going to perform and multiply it by the probability of a success. And then here's your standard deviation formula. It's a little bit longer and looks very complicated, but it really isn't when you put it into practice, which we're going to do an example of that right now. Okay, so for our example, we have the setup of during one season with the Miami Heat, LeBron James had a free throw success percentage of 79%. So I already see, here's my p-value. This was his percent, his probability of a success. It says assume the free throw shots are independent, and that is that the success or failure on one shot does not affect the chance of success on another shot. LeBron is going to shoot 600 free throws. Okay, first we're going to check that this actually qualifies for a binomial experiment. So I'm going to pull this down. I don't know if we can show it on the same page. We have to check that all four of those qualities are hit here. So one, are there a fixed number of trials? I would say yes, because he is going to stand there and shoot 600 of them in a row. So fixed trials. We're good there. Are there only two outcomes possible for each trial? Well, each trial would be a shot, so he would either make or miss it, so a success or a failure. So two outcomes are make or miss. So check there. Is the probability of success the same on each trial? So this one we had to assume it. It says assume that they are independent and that you're either going to make it or miss it. So I'm sorry, I guess that's 4. Are they independent? Here it says yes, they are. Now, in practice, I'm not sure if that would be true. If you're standing at the free throw line and you miss several of them in a row, I feel like that could start to get in your head. You might miss more of them then because you're kind of in your own head about it. Or someone, you talk about like getting on fire or being hot, like if you make several of them in a row, now you're feeling good about it and you're more likely to make the next ones. So I'm not sure that that would always be the case. In context of this problem, they're saying let's go ahead and assume that they are independent though. And then the last one would be, are the probabilities the same at every trial? And it would be, yes, here, his P is going to be that 79% at every trial. He has a 79% chance of hitting any one of those. So here we could say, yes, this does qualify then as a binomial probability. So out of these 600 free throws, how many would you expect him to make, give or take how many? Okay, expect, we talked about that in our last section. Anytime they ask you about how many do you expect, that is talking about the mean. So first we want to find the mean, and we have a formula for that here. To calculate the mean, we do N times P. So that's the number of trials, 600, times the probability of a success, which is 79%. So when we calculate that out, that comes out to 474 expected successes or made shots. So that answers this part of it. How many do you expect him to make? Like, we figured that out. The second part is give or take how many. That plus minus amount is always the standard deviation. So now we need to use the second formula. So what's this plus minus amount? Well, it's the square root of what we just calculated. In P, we just calculated. So that part of it's the same. I'm going to write it all back out, but we already know what that is. And then the only difference here is that you then multiply also by the complement of that percentage. So because this was 79%, you also put in here 1 minus 0.79. That's the only addition there. So we got the square root of 600 times 0.79 times 0.21. So practice putting all of that in your calculator. Depending on your whatever calculator you're using, how you want to type that in is going to be different. So don't just copy this down. I'm going to tell you what the answer is. It should be approximately 10. But I want you to make sure that you get that. So do take a second, make sure that you know how to enter that in your calculator to get that value. So what I would say overall for my final solution here is something like, I expect him to make 474, give or take 10. I could say that. Or another way we could say that, just kind of depending on the phrasing or maybe how MyLabs Plus asks for it, you could say something like, I expect him to make between, and maybe go ahead and add and subtract that to it. So if you take 474 and subtract 10, that would be 464. And if you do 474 plus 10, you would get 484. So you could also make that statement.